Hi everyone, my name is Scott and I work at Facebook, as Josh has already said. I work in the open source department, which is currently a department of 3. It used to be 2, but we hired somebody else that started on Monday. And more or less I work on the infrastructure, or anything PHP related within Facebook, which is the programming language we use for the front end. Anything that's open source sort of falls into my domain. So while I don't actually work on the underlying site that you guys see, I work on the sort of infrastructure that keeps it up and keeps it running. So I'll start by talking a little bit about what do people actually do on Facebook, and just give you some sort of random useless statistics that sort of show the problems we face that we want to scale a site that's the size of Facebook. First is we spend all the users spend over 8 billion minutes every day, which is roughly 15,000 years. It's just sort of mind-blowing. And I think it's the average user spends about 55 minutes a day doing things on Facebook. And roughly that works out 5 billion pieces of content are shared every week, be it web links, news stories, blog posts, or notes. And then when it comes to photos, we sort of measure them separately. There's 3 billion photos uploaded every month. So we're actually the largest photo sharing website on the web. We're bigger than Flickr and any of those other ones out there, TwitPic, YFrog. And then there's you guys. There's over 1 million Connect and platform developers that sort of use the Facebook platform. And I went to town stealing little graphs that we had. So, so Facebook is basically the largest social network in the UK, US, and Canada, and like many other countries. But actually, Facebook is very international. Over 70% of the users are actually outside of the United States. And for that reason, we built a translation system in order to sort of engage our users and help get them to translate the site for us. So there's 70 translations at the moment. And then when the tool was launched, it took less than 24 hours to translate everything into French. So all the French speakers out there were sort of helped us translate the site for us. So when it comes to scaling a website like Facebook, or sorry, a traditional website, more or less it's your data and you work with your data and it's stored directly on your database, and there's sort of no interaction between anyone else. So if it's a bookmarking website, it's just your bookmarks you access, or if it's webmail, it's just your webmail that you're looking at. And those things are fine to scale. So as you get more users, you just start adding more servers, and then your servers will get bigger, and then you'll start having to shard based on users. So you put certain users on certain servers, and it sort of progresses that way because no data is sort of interconnected. But then we've got Facebook. So Facebook's got Bob's data and it's stored on all these different servers, and it pulls in data from his friends' newsfeed. Anything he's done falls into his newsfeed and any of the other friends. So it's sort of aggregated from all the different sources. So we can't just sort of set it on one server. So that sort of leads us to the clustered approach and sort of distributing everything. And on average, the user has about 130 friends. So if you take the nice newsfeed, essentially we're saying there's 400 million active users, so there's 400 million unique home pages there, and it looks different for every single person that's out there. And for one person, we need to like scour hundreds or thousands of different data sources and sort of pull them all in and aggregate it. And all has to happen in milliseconds. Nobody's wanting to sit and wait for sort of the page to load. So the stack that we use to sort of facilitate all this is sort of the standard traditional web stack. So it's just load balancer. It goes in, distributes the web request to a bunch of web servers that we have. We use PHP as our front-end language. And then there's particular services here, and I'm going to talk a little bit about each of those. OK. So we talk about our web server, but this is PHP. And there's various reasons why we like PHP. It's simple. If we can hire in new people that come work for us, even if they don't know PHP, the syntax is so similar to C and Java and what's out there that the sort of new engineers can pick it up really quickly. Our favorite example is Hello World. Hello World in PHP doesn't even actually require any opening tags. It's just text because it's a templating language. OK, so we gave some problems. PHP is problematic for anyone that wants to scale, especially here at Facebook. So there's high CPU usage. There's high memory usage just from the way the language works because it's an interpreted language. It's hard if you want to reuse your logic in other systems. So if you've got some business logic written in PHP, if you want to use it in, say, some of our C++ services, some of our any of the services that we've got out there, then have to rewrite the code. And if something modifies, it has to get modified across 4 different languages. So somehow bugs might sneak in. And most other sites out there just go, oh, write some PHP extensions. But the PHP extensions are hard to write for a PHP developer because there's C, and then there's lots of macros in there, and it gets sort of kind of confusing. So PHP came up with, Facebook came up with hip hop, which you probably may or may not have heard a little bit in the last couple of weeks. Yay, nay. OK, sort of. For those that haven't heard about it, it's essentially a code transformer. So it takes PHP source code, and then it translates that directly into C++. And then we use a sort of normal compiler to do that. Just a normal G++ to compile it into machine data and push the binaries out to all of the servers. And the reason we can do that is because we don't actually use much of the fancy features that PHP has. Most of it's just standard variable assignment, for loops, function calls, and sort of branching statements. And then there's all the magic stuff that PHP has. So if you get any tech people in the room, they'll be familiar with variable variables and eval and variable function calls, and doing includes within functions. So, but most of this looks like it's sort of very similar to C++. And because there's not that much magic used, we're able to sort of get the performance improvement from the mundane stuff, but from the magic stuff, it sort of falls back to the way that PHP normally works. There's a little bit of the optimization strategy. So we see here, we can sort of convert these all directly into C++. So classes become C++ classes, static methods and properties. If they aren't going to change, then essentially these can be replaced verbatim. And any of the magic stuff, you still do all the, basically what PHP does with the dynamic stuff, hip-hop, also does. So for those, you won't get much performance improvement, but for everything else, you do. And roughly the process for this looks like this. So when we go to deploy a new version of the site, we sort of point hip-hop at the code base, and it goes through the various stages that are behind me. And then at the very end, it sort of puts out a really large binary. And that really large binary, we just sort of put onto the tens of thousands of servers that we have, and then it starts serving the site. So that's more or less just our web front. We use PHP because it's fast. We need to do things quickly. We want to be able to make changes, and then we want to make changes. We want to see it like instantly appear on our own development sandboxes. We don't have to wait for ages for something to compile before we can actually test it and make sure it works. So that's one of the reasons that we use PHP, because we need to move fast, change things, break things, and so forth. So services. We have a lot of services at Facebook. I'll give you a better idea of the back-end services that we have. Okay, so we want something to be quick. We don't want to have to deal with any overhead or deployment of maintenance problems. So if you're going to go create a service, then we want you to make sure that we actually need to create a service. It's not just doing it for the sake of doing it. And if we can, we want to create a common framework that can be sort of utilized across different projects. So we created, actually I'll just show you some examples in a minute, but it comes down to we create a service when we need to, because then other programming languages can sort of talk to that service directly rather than implementing it in each language. We choose the right language for the job, so we use C++ for some of the search stuff, Erlang for doing the chat, and we've got Java for Hadoop, and we've got Python for doing friend feed. So friend feeds, we needed a high-performance web server, so it's written in Python because everyone has an open connection to that when they're sort of pulling in their data on friend feed. That's one of the things we sort of open sourced. Okay. So this, I know this is 9:10 now. Oops. Okay. Thrift. Thrift is one of these tools that we use. You've probably used it here. It's a way for us to sort of communicate across all the services. So it's like sort of a connection generator. So you sort of define your data format, and it'll produce bindings in C++, Python, Java, Ruby, Erlang. So it'll generate the code for you, and you can sort of use it to sort of pass data in between each of the services without having to sort of implement that yourself. There's also some various other protocols, so you can decide how you're going to talk to it directly via the socket, or you're going to use JSON. And Thrift is one of these things that we like open source, so it's in the Apache Incubator, and you'll see it on Last.fm, reCAPTCHA, Perset, which is the thing that Bing acquired, and Hadoop uses it for its serialization. So it's just one of these technologies that we sort of went to give out there. Next is my favorite one, syslog. So for logging at Facebook, the standard way to do it is use syslog, and then you just pass all the data remotely, and it goes into the server. Unfortunately, that died because we store quite a lot of data. That's the best way to put it. So we went for Scribe, and Scribe sort of funnels all that data down. So as the logging is generated, it sort of passes it into one server, and then it funnels it down to the next one, and so forth. And we store 25 terabytes of data a day, or 150 billion messages per day are stored when you're just accessing the website. And we have a lot of data, there's no doubting that, and we have to aggregate it. So Scribe is what we developed, and we open sourced. It's actually used by a lot of other people now. I think Twitter is probably the biggest user of it at the moment.